travel in time to our past and to our future? How does it relate to light? In our universe so far, what is the fastest thing we know of? Light. Would it be possible to go at the speed of light or even faster? What would it feel like? Let's do a thought experiment. If something can go faster than light, we can predict the future. Pretend there's a cup in front of you. Pretend the cup suddenly broke. Now assume that sound was faster than light. Okay, since we're pretending that way, we would hear it breaking first before we could see it actually happen. But in real life, sound is super duper slow compared to light. For example, the sound waves reached your ears first before the light waves reached your eyes. In that example, you predicted the future that the cup would break by hearing it before you could actually see it happen. Now, if something was faster than light, we could see it happening in our heads before we could actually see it happen. Oh, now I get it. That's why Einstein said that we can't pass the speed of light. Wait, what is the speed of light? 300,000 kilometers per second. That is super fast that I can't explain it in my words. Somebody made sure that we can't pass the speed of light because the mass will increase infinitely. Which means somebody wanted us specifically not to see our future. But why? Why would mass increase with speed of light again? Let's take this example. Thought experiment number 2. Pretend there's a big boulder. Pretend a man was trying to pull it. Now, pretend there's a speed of light energy pulling it the opposite way. Then the man would feel that the boulder has increased by infinite mass. That's why E equals mc squared, the God's equation. Now I'm going to tell you a scary story of a cat that was both dead and alive at the same time. A great scientist named Schrödinger did a thought experiment like we did. He did this thought experiment. He got a cat and put his cat in a box. Then he put some radioactive materials into the box and closed the lid. He wouldn't know if the cat was dead or alive until he opened the box to find out. It could have been dead because of the radioactive materials, or it could be alive because it survived the radioactive materials. Schrödinger said that the cat was both dead and alive at the same time. How could this be possible? It's the same way I gave you that possibility of light being a wave and a particle at the same time, but this time it's with the cat being dead and alive at the same time. If light was a wave, it would have infinite possibilities of the future. But if light was a particle, it would only have one future for each person. How do we know if light's a wave or a particle? Has there been any experiments done? In quantum mechanics, the most famous experiment done for this is the double slit. A great scientist named Thomas Young did this experiment. Do you want to know what the results for the science experiment were? When light was being observed, then it would be a particle. But when it was not, it would be a wave. Which means when somebody was observing it, there would only be one outcome. But when somebody was not observing it, there would be infinite outcomes, like the cat that was both dead and alive at the same time. Which leads to multiple outcomes happening at the same time. When we observe it, it shrinks to one. How come light knows if we're observing it when it doesn't have eyes or a brain to see us or know? started its journey. Scientists did this experiment in real life, and light knew that they were going to put an observer in the future and change it into a particle. It means light can see the future and change the past too. Thinking already? I know. Don't you think we unlocked one of God's secret codes? Setting off, Prince. Einstein got really spooked out for a reason. What do you think he got spooked out for? He got so spooked out, it made him say, "Spooky action at a distance." I'll tell you in my next Quantum Mechanics Web Series episode. Watch out for Quantum Mechanics Web Series episode number 2. If you haven't watched episode 1, I highly recommend for you to go watch that and then come back to this. In our last episode, we talked about how nothing can go faster than the speed of light. In this episode, we're going to be talking about the 3D of time and what spooked out Einstein. Welcome to episode number 2 of Quantum Mechanics. My name is Prince. Einstein said space and time are not different. They're the same. Let's do a thought experiment to understand space-time. Thought experiment number 1. If you take a point in space, go left, right, up, down, forward, and backward of that point, you are in the 3D of space. Now let's do the same thing with time. The 3D of time. Stay with me because this is going to be mind-boggling. Now let's take a point in time. If there's a point in time, if you want to go left and right, it won't be possible. Because if you want to go left, you would have to go back in time. Which means you can only go to the future. Half D of time. Come on, we need more than that. What would it feel like to be in a 1D of time? I know I already told you that you could go back in time and go to the future. What would it be like to be in a 2D of time? Thought experiment number 2. In 2D of time, I can be multiple things at the same time. I could be a scientist, an artist, and a musician, and a dog, and a cat at the same time. Well, actually, let's just stick to the humans. If I can switch all my realities from one thing to another and go back and forth in time, that would be the 2D of time. Are you guys still with me? Are you guys ready for the 3D of time? In 2D of time, we're still on the Earth and following the known laws of physics. In the 3D of time, we can study the physics that hasn't been searched yet. Maybe a parallel universe or a multi-universe. Who knows what could be out there? If I can travel from multiverse to parallel universe and from parallel universe back to Earth and do these multiple things, that's the 3D of time for you. Let's do a magic trick with the coin. Pretend you and your friend each have one coin. Pretend you guys flip the coin and put it in a box so you didn't know what the result was because you put the lid on the box. After a few days, I decide to open my box and see what I got. There are 2 possibilities, heads or tails. If both of us open the box, there are 4 possibilities, heads and heads, tails and tails, heads and tails and tails and heads. In quantum mechanics, the possibilities are reduced to 2. If I got heads, I know that my friend got tails. And if I got tails, I know my friend got heads. But never heads and heads, or never tails and tails. That's 50% reduced probability. Wow! How, you might ask? I know, through quantum entanglement, which spooked out Einstein. Whenever I talk about coins, you should think of them as subatomic particles, like electrons and nucleus. Just like a coin flip, an electron has something called a spin. Quantum entanglement, let me explain. If you have two coins and put them together, they'll become an entangled pair and will communicate faster than the speed of light. Now, how are they connected? How are they talking faster than the speed of light? And how, just how or what technology are they using to communicate faster than the speed of light? That's what spooked out Einstein. He thought it was magic. Even today, nobody knows how entanglement works. Scientists don't know how photons and electrons are communicating to each other when entangled. Before the Big Bang, everything was connected. Planets, atoms, photons, neutrons, electrons, all of them were connected. But when the Big Bang erupted, everything split up far, far away into space. Your atoms might be entangled with a different planet on the other side of the universe. Maybe their coin flips are connected to your coin flips now. I wonder where my entangled atom partners are. Signing off, Prince. In my next episode, we will talk about quantum superposition and the first ever quantum computer.